Hello, my peeps. This is Mr. Avan again. It is Thursday, the 26th. Man, time is moving by fast. Just the days keep rolling by, and we just keep spending more time at home. And I don't know what day it is anymore, but I looked at the calendar, and it's Thursday, so it's time for another group of videos in math. I want to give a shout out to Carly Dunn, who asked for more videos. Where are you guys at? Been waiting for that. I would really appreciate it if y'all could mark your assignments done, so I know you're out there, that you're watching the videos. I know Carly has done some of the other videos, and she says she is waiting for the next one, so here it is. Alright, the next set of videos are for lessons 26, 27, and 28, and it's all about comparing mixed numbers and improper fractions. So again, when you're on that LEAP test or you're taking a district test, they're going to give you some numbers or give you a table, some mixed numbers. They're going to say, okay, which ones are biggest and which one are smallest, or can you group these from smallest to biggest? Well, today I'm going to give you the knowledge to be able to do that. So hang tight, and here it comes. Roll it.
At the whiteboard, Mr. Avans, comparing fractions greater than 1. Hit it.
Comparing fractions greater than 1, lesson 26. So in lesson 26, 27, and 28, they're all doing the same thing. We are using the same skills that we learned in 24, 23, 24, and 25, where we're going to have to convert mixed numbers to improper fractions or improper fractions to mixed numbers so we can compare the two. So in 26 and 27, we take it in baby steps by giving you a number line. We plot them on the number line, and we decide which one is bigger and smaller. But like I said, first step is that you've got to convert first. So we'll make that decision in a minute. Time out. Yes.
Something, Mama needs. I thought Mama was talking with you.
Okay, I just got interrupted. My little girl was trying to do a dance class, and she didn't know where she was at. But let's get back to this. So we have a number line here from 7 through 9. That's 7 whole numbers, 8 whole numbers, 9 whole numbers. This is problem 2A, problem set, page 129. So we're doing 2A and 2B. First thing we're looking at is 2A is where do these fractions end up? These are all fractions greater than 1, of course. Alright, let's look at 2B, and that's a little I. Little I means that it's the first one. And we have 8 2/4 and 25/3. Now here's the confusing part. How do you know where 25/3 is? We know that 8 2/4 is going to be somewhere after 8. And over here on the second one, we know that 8 2/4 over here is going to be somewhere after 8. But where is 25/3? And for the second one, where is 79ths? So let's look at this first one here. We need to figure out where 25/3 is. So, first of all, I can see that this one is broken up into fourths. So let's go ahead and make fourths up here. So in order to create fourths, I have to divide it in half, and then I need to divide my halves in half to create quarters. Alright? So that's 7. This is 7 1/4. 7 2/4, 7 3/4, and then 7 4/4 is 8. So let's break up after 8. We have the half, break the halves in half, and we have quarters. So that's 8 1/4. Put an 8 here. 8 2/4, and 8 3/4, and then we get to 9. Alright, now I can tell already that my 8 2/4 is right there after I broke it up in fourths. I'm going to get special colors for that. So let's use pink. I'm going to use pink for 8 2/4. I'm going to circle 8 2/4 right there. Alright, so we have that right there. And remember, we're comparing. Remember, whenever you do comparisons, you're comparing the left to the right. So if the alligator is opening its mouth this way, it's greater than. If it's open to the left, it's greater than. If it's open to the right, it's less than. And of course, that's an equal sign. Alright, now we got to deal with this 25/3. What were the steps that we use to figure out where improper fractions are as a mixed number? How do we convert 25/3 into mixed numbers? Well, we got to look at that denominator. The denominator is telling us that it's in thirds. So we need our multiples of 3 to do a division problem. We're basically doing 25 divided by 3 equals. The remainder is your fraction, and your answer to 25 divided by 3 is your whole number. So let's do our multiples of 3 right here. We have 3, 6, 9, 12, 15, 18, 24. Looks like we're going to have to stop at 24. That's 1, 2, 3, 4, 5, 6, 7. What did I do wrong here? 3, 6, 9, 12, 15, 18. Oh, we forgot one. Let me start over. The multiples of 3 are 3, 6, 9, 12, 15, 18. 3 plus 18 is 21. And then 24. Okay. So that multiple is 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 3 is 24. Therefore, our whole number for 25/3 is 8. Okay? How many thirds are left over? So that is 24/3. And we're coming from 25/3. What is that left over? 24/3 minus 25/3 is 1/3. Okay? So your remainder is 1/3. 8 1/3. What was the other way we did it? We also did it as a division problem. Let's do 25 divided by 3. We said 8 times 3 is 24. I subtract 24 from 25. There's my 1/3 right here. You see it? 1/3. Okay, so where is 8 1/3 up here? Well, we have got to have an accurate number line here to tell me where the thirds are. Let's see if we can do that here. So to make thirds, remember that's 2 lines, and I'm going to tell you already, if you don't know, the thirds are usually bigger than the quarters. So 1/3 is bigger than 1/4. So this is 7 1/3. This is 7 2/3. And this is 7 3/3 or 8. And then we have to do the same over here. Make your big lines. This is 8 1/3. This is 8 2/3. And then we have 9, which is 8 3/3. Okay? Let's put a mark on where 8 1/3 is. We're going to make that one green. Alright, so let me circle this. The green one is 8 1/3. Okay, now we can compare. 8 2/4 right here looks like it's bigger than 8 1/3, and that is true. Now, one other way we can tell to make sure we're absolutely right is to turn 8 2/4 into the same fraction as this. We'd have to make it in thirds. Let's see if we can do that. I know this is a lot of work, but we're just going to double check. So we turn this into an improper fraction by multiplying 8 times 4. 8 times 4 is 32. 32 plus 2 equals 34. So it's multiply, add, back over 4. So this would be 34 over 4. Now, we have two different denominators here. What do I need to do to compare these two? I have to turn them into equal fractions, or they got to have the same denominator. The closest denominator we can use is probably 3 times 4. 3 times 4 is 12. So that means I have to multiply this times 3 over 3 and multiply this one times 4 over 4. So let's do that. Okay, this is more work than Eureka is asking for, but I'm going to do it anyway. 34 times 3 over 3 equals, multiply across, 3 times 34 is 102 over 12. And if I multiply 25 thirds times 4 over 4 to get 12 on the bottom, 4 times 25 is 100. 4 quarters is 100 over 12. Well, look, just barely bigger. 102 over 12 is bigger than 100 over 12. Okay? So we use many different ways here to compare. We used our number line. We turned this into a mixed number. We compared our mixed numbers on the number line, and we saw that 8 2/4 is bigger than 25 thirds. That's a lot of work to find that out, but that's what you got to do. All right, let's look at the second one. 70 over 9 and 8 2/4. Well, we already have 8 2/4 up there. That is the pink dot. All right, so we need to find 70 ninths. Now, how do I find a mixed number with ninths? I need my multiples of 9, and we have to divide. So let's use the green color. No, we already used green. Let's use the red color for 70 ninths. So I'm going to circle it. Okay, what are my multiples of 9? Got to go all the way up to 70? Okay, 9, 18, 27, 36, 45. Not there yet. We got to go all the way up to 70, close to 70. All right, 9 plus 45 is 54. 9 plus 54 is 63. And 9 times 8 is 72. Well, 9 times 8 is too big, so we got to go with 9 times 7. Okay, so 70 ninths, or 70 divided by 9 over 9 equals, what do we say? 7 times 9 is 63. So we have a 7 as a whole number. 7 times 9 is 63. How many more to get from 63 to 70? 63 to 70, that's 7 more, so that is 7 ninths. Or we could say, what is 63 ninths minus 70 ninths? That equals 7 ninths. Alright? I can also show you the division problem. So let me do that up here. We're dividing 9 into 70. 7 times 9 is 63. I have 7 left over, so that's 7 and 7 ninths. 7 and 7 ninths. Okay, I have 7 and 7 ninths and 8 and 2/4. So let me rewrite that. Let me put it right here. 7 and 7 ninths. Where is 7 and 7 ninths here? Do I really need to know where it is on the number line? 7 and 7 ninths is going to be somewhere close to 8, but it's not bigger than 8. This is 8 and 2/4. This is 7 and 7 ninths. It's below 8, so it has to be less than. Use your common sense here and know that 7 is less than 8. I don't have to worry about the fractions here. 7 and 7/9 is less than 8 2/4. Okay, we're going to do another one like this in lesson 27, and then we'll show you one more in lesson 28. See you soon. Okay, comparing fractions greater than 1, lesson 27. All right, we're back. Okay, now in lesson 27, they take away the number line. They want you to start comparing these fractions in these mixed numbers greater than 1 just by trying to figure them out by converting. In this case, for 2A on the problem set, they want to show you an area model. So I'm going to teach you how to make that area model, but you still have got to convert in order to find this out. For 2A, we have fifths and sevenths. Those are two denominators. Those are two fractions that are hard to compare just by looking at them. We need the model to help us out here. Or you've got to turn them into improper fractions, and then you have to make the denominators the same by finding equivalent fractions. But we're not going to do that this time. We're going to use our area model to help us out here. Now remember, when we made an area model before in class, I said the best way to compare two things is to make equal, like one big rectangle, and make sure that both fractions that you're comparing are equal on either side. In this case, I went ahead and thought ahead. Since this one is 2 3/5, I know that we're going to have something bigger than the whole number 2, but less than 3. If I look at this one, let's convert this one and see if it is over 2 and less than 3. Alright, so let's convert. Improper fraction, 18/7. Several ways of thinking about it. How many sets of 7 are in 8? What is 18 divided by 7? And what is our remainder? So first, let's look at it as 18 divided by 7 equals what? Alright, we could say that's over 7. 18 divided by 7. We need our multiples of 7 again. So what are they? They're 7, 14, 21. 3 times 7 is 21. That's too big. 2 times 7 is what we're going to have to use. 2 times 7 is 14. So I know already that my whole number for 18/7 is the whole number 2. And I need to figure out what my remainder is. What is my remainder? Well, what do we have left over? Let's look at it as a division problem. 2 into 17. I'm sorry, that's 7 into 18. We said it goes 2 times, so there's your whole number, 2. 2 times 7 is 14, and the remainder is 4 over 7. Okay? So that's 2 and 4/7. That's a subtraction sign. 2 and 4/7. So this is really 2 and 4/7. Alright? Okay? Another way of looking at it, we could have said, what is 18/7 minus 14/7 to get our remainder? That equals 4/7. That's another way to find your remainder. Okay, so now we're looking at 2 3/5 and 2 4/7. Both of them are less than 3, but which one is bigger? Let's find out. So on the top one, we're going to make, I'm going to keep my black marker out, but we're going to do blue for 2 3/5, and we're going to use purple for 2 4/7. Alright, I'm going to use black to make my partitions. This one has to be in fifths. How do you make fifths? You make 4 lines, that gives you 4 spaces. 1, 2, 3, 4. That's fifths. 1, 2, 3, 4. That gives me 5 spaces. 1, 2, 3, 4. Now the one on the bottom is in sevenths. Oh, that means 6 lines. I gotta make 6 lines. Let's see if I can do it. 1, 2, 3, 4, 5, 6. Whew, that's hard to do. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, these aren't extremely accurate. I did the best I could. What we need to see is which one is clearly bigger than the other. Now let's shade them in. We know that both of these have 2 whole numbers shaded in. So I'm just going to do this. That's shaded in. This is shaded in. And then we need 3/5 more. So that's 1, 2, 3. Alright, let's do the purple now. This is going to be close. Oh, Eureka, why did you do that to us? Okay. Here's 1 whole number. There's 7/7. There's another 7/7. And now I need 4/7. So that's 1, 2, 3, 4. That is too close. That is too close for me to tell. So what do I have to do? I've got to go ahead and turn these both into improper fractions and then find equivalent fractions. So let's do that. Darn it. Okay. So what I'm going to do first is I'm going to turn this into an improper fraction. 5 times 2 is 10. 5 times 2 is 10. 10 plus 3 is 13. So this is actually 13/5. Now what is my common denominator here? We're going to have to use 5 times 7. So let's start this over down here. So 13/5 times 7/7. 7 times 3 is 21. 2 plus 7 is 9. That's 91/35. And then over here, I've got to multiply 18/7. 18/7 times 5/5. We get 35 on the bottom. So that equals 5 times 8 is 40. 4 plus 5 is 9. 90/35. Look how close these were. The model would not help me here. 91/35 is 2 3/5. And 90/35 is 18/7. So that means greater than. Guys, this is probably some of the hardest work you're going to do in fractions in Eureka in 4th grade. This is tough. The best thing you can get out of this, if you can't be this accurate, if you can't do these larger numbers here, these larger improper fractions, just do your best trying to convert these. Do your best, practice, look at the other Eureka videos to help you out, and I'm going to meet you again for lesson 28.
Man, that was some hard math. But now we're on lesson 28. Yeah, man, I love the reggae sound effects. Hit it!
Okay, no kidding aside, that is some hard fraction work. But what I'm going to try to show you now is in lesson 28, just for the fun of it, we're going to do the problem set number 1 and what it says. Let's do some RDW, read, draw, and write. It says, the chart to the right shows the distance 4th graders in Miss Smith's class were able to run before stopping for a rest. So we have a table, we have the name of each student, and there's a bunch of students, and we have the distance in miles that they ran. It says create a line plot to display the data in the table. Data means numbers. What are the numbers? Okay, remember a line plot is an XY line plot with X. Let me show you. Let me get a pen and a square. This is a triangle, or we call it a square as well. This is going to help me make some straight lines. What we're going to have to do is create a line plot. I want to use the whole length of the paper sideways, so let me go ahead and start that. We have a line plot this way. That's one axis. And then our second axis, or our second dimension, is this way. Okay? And on the bottom here are going to be the names of each student and the amount they ran. And over here, on going up and down, is going to be, I'll tell you what, we'll make the up and down the names, and we'll make the left and right the number of miles they ran. Now, how do we compare all these mixed numbers? Let's take a look at the denominators. We have some that are in halves. We have some that are in fourths, and we have some that are in eighths. Well, the good part about that is that it's easier to compare seconds, fourths, and eighths. So what we're going to have to do is we're going to have to convert them to improper fractions, and then we want to use the fraction or the denominator that has the smallest parts so we can compare them all. That means the common denominator here is going to be an eighth. So after we do improper fractions, then we convert to eighths. So let's do that first. We have 2.5. I'm going to do this quickly. What is 2.5 in eighths? That's what we need to figure out. Let's get an improper fraction first. So that's 2 times 2 is 4, plus 1 is 5 halves. How do we get that in eighths? We multiply 4 top and bottom, and we get 28ths. Okay? So that means on this side, or this left and right here, we need eighths. So let's do that. I'm going to make some hash marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm going to stop at 24. Alright, let's do the next one. 1 3/4. Again, we've got to get that over to 8. So let's do the improper fraction. 4 times 1 is 4. 4 plus 3 is 7/4. How do we get that to eighths? We've got to multiply 2 over 2. That gives us 14/8. So I'm going to do a few of these for you, and then you're going to have to figure out the rest on your own to plot this. Okay? Let's do the next one here. I'm just going to do a few of these examples. This one's already in eighths for you, but we need to figure out how many eighths. 8 times 2 is 16. 16 plus 1 is 17/8. That's for Bobby. So far we have Joe, Ariana, and Bobby. Now for Morgan, that's an eighths too. That's already figured out for us. So we have 8 times 1 plus 5. 8 times 1 is 8. 8 plus 5 is 13/8. Okay, let's see, that's Morgan. Jack is in 8. Let me do a couple down here. Let's do Tyler, and then we'll leave the rest up to you. So Tyler is 4 times 2 is 8. 8 plus 2 is 10. So that's 10/8. Okay, now let's turn this around and let's finish off our line plot. We have our names here. We have Joe, Ariana. I'm just going to say Ari, shorten it. Bobby is going to be Bob. Morgan is going to be Moore. Jack we have Saisha, and Anson is going to be Ann. And then last but not least is Chandra. We'll just call her Sean. Okay? Now how do we plot this? Well, remember, for line plots we make X's. So how many did we say Joe was? We said Joe was 28. So each one of these hashtags here, or each one of these hash marks, are going to be an X. But I'm not going to really count these. I'm just going to count the number of 8s I have. So I'm just going to write over here number of 8s. So Joe would be 1, 2, 18, 19, 20, all the way to the top, huh? Right, next we had Ariana. Ariana said she had 14/8 of a mile. So we have to do 14. 1, 13, 14. Okay? And then we have Bobby. Bobby is 17/8. So for Bobby, do 1, 2, 13, 14, 15, 16, 17. Now look, my 14 wasn't exactly the same for both of them, but I can see which one's bigger and which one's smaller. And I can see that just by looking at the number on top too, the numerator. So for Morgan, we have 13, 1, 13. Now, it looks like I skipped a little bit here, so my 13 looks equal with 14, but I know that 14 is bigger than 13. It might help too if we put the improper fraction there too. 13/8, 17/8, 14/8, and this one was 28. Okay, let's go over here to Tyler or Ty. We have 1, 2, 3, 10. All right, 10/8 by there. Okay, so your job is going to have to be, you're going to have to finish converting these over here, changing them to 8s if you have to, and then filling in your X's over here. The whole point of this is to use this graph, and you go to the next page, page 138, and you're going to use your line plot to help you answer these problems. Who ran a mile further than Jenny? 1 more mile than Jenny. Who ran a mile less than Jack? Now remember, in order to figure out how many miles they ran by looking at the 8s, you need to be able to compare your improper fractions. Let's see, 28 was also, for Joe, 28 was also 2.5 miles. What is that in 8s? Well, 8 divided by 20, or 20 divided by 8 would be 2 times 8 is 16. So that would be 2 and 4/8. 2 and 4/8. Well, that's the same as 2.5, okay? So you're going to have to be able to convert these in order to understand these questions on this page. Who ran a mile less than Jack? 2 students ran exactly 2 1/4 miles. Identify the students. How many quarter miles did each student run? This is really tough, guys. If you guys can answer this, that's advanced work. Very advanced. I want you guys to also check out the Eureka videos. See how Mr. Hallbecker does these. He's going to show you how to do this homework page over here on page 139. I showed you my technique of doing this. The homework page looks a little easier. You're comparing with halves and fourths instead of 3 different denominators. The homework page might be a little bit easier on page 139. Guys, do your best on these. I'm not expecting you to master this stuff. This is some really hard stuff. Do your best. Get good at converting these mixed numbers into improper fractions, and you'll be way ahead of the game. I hope you guys have a good evening, and I'm going to put out a new video probably on Saturday evening. Have a great weekend too. I hope your family's safe. I hope y'all can chat some more on the Google Classroom. I open it up for posting. If you want to post something, say hello to your friend. Let's start talking. Get on Google Classroom. Say hello. Let me see how you're doing. Tell me when you finish an assignment. Ask me a question. I'll give you a specific answer on a video. I've got the time now. Let me know how you're doing. And peace.
Your love is a light for I realized that so much when I first met you.